What's up, guys? It's Lionel the Builder back again with another video. And a lot of times us new guys, us new junior developers, we go straight to the code when we're trying to break into tech. When we're trying to get hired, we just learn HTML, CSS, JavaScript. We start building things with React. Or if you're doing Python, you start building applications shortly after you learn to code, but without understanding how computer systems work. So right now, that's what I'm focusing on. I'm studying computer system design in order to go back and fill in some of the holes and gaps that I have in my knowledge of the real low levels of abstraction that go down to the initial hardware and software of a computer, how the operating systems are built to manage that, and then how we build applications which complete a certain task for us, which then is built on top of the operation system. Just things that I never really thought of before, and I'm starting to see how computers are the same way that cars are, where you can use them without understanding all of the complex engineering things within the engine, within the entire process from when you first turn the key into the ignition, what happens, to then when you press the gas pedal, what happens. Computers are the same way, and it will only make you a better programmer and a better engineer the more that you learn the complex fundamentals of how these things work. So I wrote a little bit of a blog here while I was studying, and I thought that it may be beneficial. I also posted it in the community, so please make sure that you like and share this video. Join the links in the description. We have a school.com where we're teaching people how to code and break in the industry, and we have a Discord where we're all learning and growing together. Lots of mentors in there as well. Shout out to the architects. But about this blog and understanding the fundamentals, let's just go through it. I'm gonna read it and pause and do a little bit of my take on all these different things where I'm currently at with my understanding. Let's go. How computer systems work. Let's do a quick overview of the basics of computer systems. Understanding the fundamentals. What are computer systems? At their core, computer systems are made up of hardware and software. The hardware includes the physical components like the CPU, the memory, the storage, while the software comprises the programs and the operating systems that run on the hardware. So by hardware, these are physical things, again, chips, computer, CPU, memory, RAM, the storage, and then the software is the programs that we write in code, and the operating systems that run on the hardware. This is like the mind, if you will, versus the physical, the hardware being the body. Key concepts. Learn about concepts such as input and output devices, data storage, and processing. And the guide for this, by the way, is how to understand fully how systems work. So they're saying you need to learn about the concepts such as input and output devices, data storage, and processing. These foundational ideas will help you grasp how systems interact and work together. Delve into operating systems. Role of operating systems. Operating systems like Windows, Mac OS, Linux manage the computer's resources. You could also say Android and iPhone, that's an operating system, right? Or Apple. Every time you have to update the entire that's the operating system that you're updating, which manages the computer's resources. They act as an intermediary between the users and the hardware, ensuring everything runs smoothly. Explore basic commands. Familiarize yourself with command line commands. This knowledge will give you more control over the system and improve your problem solving skills. Then we have to learn about networking basics. Computer systems often connect networks to share resources. And that's different computer systems spread out, could be miles, could be one on the other side of the world, but they have these networks of communication within. So you would also need to understand that the basics of networking, how data is transmitted, and the role of IP addresses, and protocols like the TCP and IP. I know IP is Internet Protocol. What is TCP? I'm assuming that's like transfer. Let's see what TCP is real quick. Uh, what is that again? TCP IP stands for what? No, IP is what's TCP? I said that complicated. Transmission Control Protocol. Right. It's the foundational protocol for the internet. Here's a brief overview of both. The protocol ensures reliable, ordered, and error-checked delivery of data between applications running on hosts communicating over an IP network. TCP is connection-oriented, meaning it establishes a connection between the sender and the receiver before data can be sent. It handles data segmentation, acknowledge of received packets, retransmission of lost packets, and reassembly of received packets. Right. And then Internet Protocol is responsible for addressing and routing packets of data so they can travel across networks and arrive at the correct destination. So I'm looking at this as like the Internet Protocol is like the post office, and then the TCP is like the delivery drivers and everything like that, like the actual, like there is routes out there. That will be the internet protocol, how the postal service automatically has the routes, whether if anyone's driving on it or not. And then the transmission control protocol is the actual process of you walking in, handing them the box, them sorting it, figuring out who's going to drive it on what day and stuff like that. Anyway, getting back to it, importance of security. As you learn about networks, also consider the importance of cybersecurity. Naturally, once we get to that part where we're learning about how the transfers happen, then we need to learn about how to make them secure. Understanding how to secure a network is crucial in today's tech landscape. Now, and this is also to show the vast amount of things that we do need to learn to be software developers and engineers, right? Then getting hands-on with programming. Start with Python. This is just a recommendation. You can start with whatever. But Python is an excellent first language due to its readability and broad application. It's used in web development, data analysis, and more, making it a versatile choice. Build simple programs. Start with small projects that reinforce your understanding of how computer systems process instructions. This practical experience is invaluable. So that's building small projects and little ideas that you have. That's when you will actually get the real developer experience, understanding what it's really like, especially when you go to build something outside of a tutorial or a guide that you're following. Building your own idea, even if it's just getting your website live and then making it look how you are happy with it looking. Then explore system design. System design principles. Zoom into the principles of system design, focusing on scalability, reliability, and efficiency. Understanding these concepts will help you design robust systems that can handle increased loads. So that's understanding, like, if you were going to design a Ticketmaster or something, what are all of the functional requirements and the non-functional requirements that you would need for that to even work software wise, user authentication, a database, a payment system, just thinking of how to actually design this thing before you even write any code in like a Figma or in some type of program, figuring out everything that is needed mentally, figuratively, physically, somewhere either on your computer, or digitally, getting that design out of your brain. The only way to properly start working on a vast, amount of software or something like that is to sketch it out conceptually first. And that is a skill that is needed, to become a better programmer for sure. Case study. Study real-world examples of system architectures. Learning from established systems provides insight into best practices and potential pitfalls. So right, learn from the elders who came before us and who have been designing systems ever since systems were created. There's no point in going at this without catching up to speed with the norms, right? With the so that like they say, you have to learn the rules of the game before you break them. You can get creative, sure, and break off into your own thing later, but at first you should learn the rules so that you can then, you know, get creative. Joining a tech community, let's just say a tech community, not the tech community, but you definitely want to join one. Join tech groups and forums where you can ask questions and share knowledge. People who you can show the things that you're growing to and get feedback, or having somebody to reach out to when you get stuck. Just having a network is super, super important for developers. There's no reason to go at this alone. Digital builders being one of them. Hop on in, join the community. Networking tips: attend tech events and meetup and connect with professionals online. Building a network is vital for learning and finding opportunities. And then, what's the road ahead look like for us juniors? The tech field is ever evolving. Stay curious and keep learning new technologies and tools. Platforms like Free Code Camp, Code Academy offer courses that help you expand your skill set. Or even here, the School of YouTube University, also school.com, the digital builders. We are creating these types of courses there that are set to take a brand new beginner to the point of where he'll be ready to build stuff for himself and then eventually land a job. Work on projects, contribute to open source, or start freelancing. Practical application of your skills will boost your confidence and prepare you for job opportunities. Starting your journey in tech can be exciting and challenging. Engage with our community below, share your experiences, ask questions, and connect with other aspiring tech enthusiasts. Remember, everyone starts somewhere, and your journey into understanding computer systems begins today. So, yeah, that's the just a brief overview to give you guys an insight on all of the things that you should require of yourself to understand. I know it is a lot. Don't let it be overwhelming though. Take your time. We don't have to understand all this stuff at one point, but at least be aware of, the vast gap from when you're first starting off and someone who has been in the industry for a while that has delved into these, rabbit holes here, which each one of these things you could probably get lost in the maze. But I just wanted everybody to, at least get the conversation going. But yeah, that's the video for today. I'm Lionel the Builder, and I'll see y'all next time.